Alright, so I'm going to start with the practice exam here. Let's jump in. It says a vector is 14 meters. That's the magnitude. At 30 degrees north of east, what is the east component? So first I have to draw, what does 30 degrees north of east? So I'm mostly going east, and then I drag a little bit north by 30 degrees north of east. So 14 meters. So my x component is going to be 14 times the cosine of 30, chosen because this is the adjacent to the angle, and my y would have been 14 sine of 30. They're only asking about my east component, which is my x. So I just need to type in 14 times the cosine of 30. Saying about 12.12. That looks like B to me. Displacement is 40 degrees south of west. So that means it's mostly west. And then I go to the south of west by 40 degrees. So it's more west than it is south, because if it was perfectly even, it would be 45. So right now it's more west than it is south, but it is a little bit of west and a little bit of south. So this would have been if it was 45 degrees. Hiker goes 15 meters north and then 10 meters at 30. So I go 15, and then from here I go 10 meters at 30 degrees east of north. So it's mostly north, 30 degrees east of north. How far east did the hiker travel? So they're actually only asking us about that part. And that part is 10 times the sine of 30 degrees. I believe that's going to be 5, but I'm a little forgetful. There we go. However, if they had asked us how far north, I would have found this component and I added it with the 15. So imagine for a second that this was, well, let's just do it. Let's just do it. 10 cosine 30, and then we would add the 15. So it would be 8.6 plus the 15 to get a total north of 23.6. Vector has components of 9 east and 12 north. The magnitude, 9, 12. Magnitude is just asking about the hypotenuse. So let's see, square root of 9 squared plus 12 squared is 15. A squared plus b squared equals c squared. Vector is 25 meters long, 7 degrees north of west. So we're starting from west. Then we go 70 degrees from there. So this is a good question. It's a good question. We started at west, and typically that means we're mostly in that direction. But because we did 70 degrees, even though we started from here, we went past 45 where it was even, and all the way up to 70. So this vector is mostly pointing to the north. It's got a little bit of west, but it's mostly north. A bird flies 18 meters at 45 degrees above the horizontal. The vertical component, 18, 45, 18 sine 45, 12.72. Just for giggles, so you guys can see it, if I do the cosine, 45 degrees, I also get 12.72. That's the uniqueness of the 45 degree angle. It says the reason we break vectors into components is because vectors only act horizontally. That's not true. Sometimes they're vertical. Angles confuse the physics. It's true if you're a student, but it's not true if you're a rock star. like you. Components allow forces to be added direction by direction. That's sounding pretty good. Let's see what the last answer options are. As soon as I can find the rest of the answer options. It is required by the equations. I mean, I guess that's also true, but as I've mentioned before, I'm going through this to prepare the answer key. So I'll improve that. I don't want that to be the answer. But it is true. Because the equations, you can't mix apples and oranges. And then the hypotenuse is never meaningful? Not never. There's still a meaning to which way I pushed it and how hard. It's just not useful for the math. Okay, so I would probably go with C. The components need to be in component form before adding the directions. I don't know if that made sense. They need to be in components before you can add them. Add these vectors. 10 meters east. 8 meters at 60 degrees north of east. The total north. Let's see. Well, total north. So again, we're doing 10 meters east and then 60 degrees north of east. So really, again, if they're asking us about north, only this one component. So I really only need to do 8 times the sine of 60 degrees to get that answer. 8 sine 60. 6.9. For an object to remain at rest, which must be true? The net force equals 0 in the x direction only. Well, I do need x direction net force to be 0, but I don't only need it in the x direction. Net force equals 0 in the y direction. Needs to be true, but not only. I do need it in both for sure. Net force must equal weight. That doesn't make sense. Net force must equal tension. That doesn't make sense. So I'm going with C. 35 Newton force acts at 20 degrees above the horizontal. So from the horizontal, I go 20 degrees above it. The vertical component is 35 sine 20 degrees. 2 ropes hold a sign in equilibrium. If one rope's angle increases, the tension in that rope... Oh, I gotta think about that. I do think this is probably a little bit harder than was going to be on the test, but let's figure it out. If I've got 2 ropes, it starts like that. Let's see. Things that would be true, my x's would balance each other. Now, if I got this rope and I chose to